Hello to everyone. This video is to document and demonstrate the operation of the simulation at firmware level of the project Sonar On Chip. The firmware simulation that will be shown consists of writing some register and testing the behavior of the circuit. The registers are presented on the GitHub repo, and also it's possible to see this on the Verilog code. It's important to mention that each SoC has 13 registers, and the complete chip will have 36 channels, each with its own independent registers. The formula to calculate the address of these registers is on the GitHub documentation. Remember these directions. In the simulation that we will see later, they will make sense. On the firmware, and using the equation given on the README file, we will write some values to the registers, and we hope to see these values in the simulation. We will write some data to the control register, register, and threshold register, and also we will introduce some data to the PCM register. Now, on GDK Wave, if we observe the address and data lines of the wishbone interface, we will see that the address that are writing correspond to the address of the table registers. For example, let's observe that when a value 18 is sent to the data line to the address 08, if we look at the firmware, again we will see that this value 18 corresponds to the data that we enter into firmware, and that the address 08 corresponds to the table registers, in this case to the control register. In the previous case, we write data to the control register of the SoC 1. Now, in the following case, we write data to the control register but from the SoC 2. We see that the data and the address line of the wishbone interface have the value that corresponds to the data that we enter in the firmware, and the address that corresponds to the control register but of the SoC 2. This shows that it's possible to write to the registers of the chip channels independently. For the register, the same can be observed. We see the data that is written in the firmware and the address to which this data is being written. In case of the threshold register, it's the same situation. Last but not least, we can see the data that we write to the PCM register. Now, with the PCM data loaded into the register, we will observe the behavior of the circuit when the output signal of the moving average filter exceeds the value that we have set as threshold on the firmware level. Now, note that when the moving average output exceeds the threshold value, the timer stops and the comparison signal is triggered. At the same instant, the latch catches the timer value and holds it until the clear signal is raised. When this happens, the timer returns to 0, and the previous process will be repeated as long as the output signal of the moving average filter exceeds the value of the threshold register. Let's also see that the timer data is sent as output by the wishbone bus. There is a time difference between the moment the timer value is captured and the moment it's sent. This is because of the delay time of the instruction fetch. This shows that the behavior of the circuit is correct. Thank you for watching this video.